We're now ready to start our coverage of two-stage completion methods. And we'll see that these can be used in a couple of ways. The first one we're going to look at is going to be a two-stage completion method where both previous stages have to complete before the next stage is triggered. So it's basically like a logical conjunction or an AND style operation. The method we're going to look at is called thenCombine. And you can see this is what it looks like. It's kind of funky. It applies a bifunction action to the results of two previous stages. So what's a bifunction? A bifunction takes two parameters and applies a function to it and then returns a single result. So it's like calling it a two-parameter method, basically. But it does it in functional interface style. And as I mentioned before, this is basically a logical conjunction. Both actions have to finish before anything else gets done. Both previous actions have to finish. There are actually two futures used here, two completable futures. There's the future that's used to invoke thenCombine, which I don't show here because this is just the method signature, but you call this method. It's a non-static method, so you have to call it in the context of some object, some completable future. And then there's the other future that's passed to thenCombine, and that's this one here. So the first parameter is this other future. And it returns a future that contains the results of applying the function action, which is this bifunction thing right here. So you can basically think about thenCompose as performing a simple reduction. If you remember the reduce method that we talked about in the context of streams and parallel streams, reduce was used to reduce things. Well, this is kind of a reduction when you only have two previous things to reduce. We typically use this to join together two paths of asynchronous execution when they're both done. So let's take a look at an example to make this more clear. This is from my EX8 folder, or EX8 project in my GitHub repository. So the first thing we're going to do here is we're going to go ahead and create two completable futures, conf1 and conf2, and they're both going to ultimately contain the results of doing some asynchronous operations. So without getting lost in the details, this first one, conf1, is going to multiply two big fractions together, and conf2 is going to divide two big fractions. But those could actually be any old computations we want. I just picked multiply and divide just for kicks. So those two things are going to start running asynchronously. And then what's going to happen is we're going to use the thenCombine method. And thenCombine is going to have this bifunction action triggered, the big fraction add method reference. That's going to be triggered when conf1 and conf2 both complete. So the add doesn't get done until both those things are done, which makes sense. We're basically joining things together. We forked off two asynchronous tasks. They run in the background. When they're both done, we add the results together. And then we're going to go ahead and we're going to print the results. So we're going to use thenExcept to print the results when all is said and done. So this particular example is pretty cool because it's illustrating how you can fork the computations and then wait for them to be finished. Now, something to note here, you'll notice that, oh, sorry. So this is going to do that computation. This is the thing I skipped. If we were doing a long-running operation here, this is a pretty short-running operation. We're just adding two things together. So we can really do that synchronously, and we're fine. But if for some reason this was a much longer-running computation, which it's not, but if it was, then we could use the thenCombineAsync variant of thenCombine, which will arrange to run the action, this bifunction, in another thread in the common fork join pool. So that's a slight variant of this approach. Now again, for this particular purpose, we don't need to do that because add is a super fast call. And honestly, if you tried to do add in the background, it would probably take longer to set it up to run in the background than it would just to add the results together. But be aware that there is an async variant of thenCombine called thenCombineAsync. In either case, whether we use the async variant or not, we can have the thenExcept call be used to finish things off. And you'll notice, by the way, that you might have the thenExcept call running in a different thread if thenCombineAsync is used or thenCombine is used. Because if thenCombine is used, you'll probably have a different thread running than if you do thenCombineAsync, because that would probably be running thenExcept in the thread that thenCombineAsync was running in, which could be different from the one that we would get if we were running thenCombine. The long and the short of it, however, is you don't really care about this. All you care about is chaining together these completion stage methods to get the proper end result. Everything else is optimization that you can fiddle around with if you want to have the behaviors be different. So that's the end of our discussion of part 1 of the two-stage completion methods lesson, which has to do with ANDing by thenCombine.